Today we are going to install. Yeah. So yesterday we installed Grafana, Prometheus. Before that we installed Helm package manager for installing these tools. I deleted that EKS cluster. EKS. So now it's creating another EKS. Okay. So I will install the Helm once again. It's almost done. Regarding Helm, any doubt? Anyone have any doubt? It's a package manager.
It finds where on the node, which node something's installed on.
No. Just a package manager. That package manager have a lot of application. Okay. We just search the application and just install the application in very simple way. And we didn't bother about the YAML file. That's the main thing. Otherwise, we need to keep a YAML file for deploying these types of application.
Okay.
Because coming to production, there are a lot of applications. So we need to manage each one YAML file separately and, applying that deployment in Kubernetes like that. Instead of that, we can use Helm package manager. So just to search using Helm command, and we can choose the corresponding package. Then easily we can install to Kubernetes. In case if we didn't choose the Helm, okay, consider we didn't go with the Helm to install these things, what will we do? We need to keep, first we need the YAML file, right? I mean, to deploying in Kubernetes, we need the YAML for Grafana, Prometheus, and some other dependencies, services there, okay, for these two applications. So for that, we need to create each YAML. And we need to apply each one. So that's a time-consuming process. That's why we are going with the Helm. Using Helm, we can just search with the Helm command, and it will list the existing applications. Then we can choose the corresponding application with a single command and install.
You have like things like apt-get or yum. Those are also package managers, right? But
yes.
Why do you need a different kind of package manager?
In Kubernetes, we are using Helm actually.
Oh, okay.
So Helm and Kubernetes are like there are so many tools we use in Kubernetes. One of the tool is called Helm.
So it's a package manager for Kubernetes.
Mostly.
Oh, okay.
Okay, my cluster is ready. So I'm going to install Helm. I will share these commands, okay? after this section. I already sort out all the things. So Helm is installed, right? So this is a version. Now I am going with the Helm command, okay? This is actually Helm command, Helm repo. It's already there, so it's skipping. Yeah, I used the same virtual machine yesterday. That's why it's all things are there regarding Helm. I think I need to create a Kubernetes cluster, sorry, namespace with the Prometheus.
One question, the same virtual machine, but you terminated, right? So
I
now
didn't
it must be
I,
the
I didn't terminate yesterday. Yesterday night I
oh,
deleted the EKS cluster, but I didn't terminate it.
okay.
Now I created a namespace, okay? So now I am using Helm command. I am pointing to the namespace of Kubernetes. See, Helm install stable Prometheus community, Prometheus stack. These things I am going to install, okay? These things. So the Helms now there is a Kubernetes running in the, I mean, in behind this. So that's why it's pointing to the namespace. See, as of now, the Helm is running with our local machine, right? So now it's deployed to our namespace Prometheus. Sometimes we need to mention the namespace too. Okay, so the stack is successfully deployed. Now I am going to edit Prometheus service. Sorry, these are the services in Prometheus. So in this stack, okay, in this stack, there are two things we can see. One is Grafana and Prometheus. Okay, that's why we called a stack with these two things. And some related things are there, like for Prometheus, alert manager there, operator there, then cube state metrics
So,
there, node
Kapit,
exporter there.
one quick
These are,
question.
yes.
Uh, so why are we installing this? Is it a task that we need to do, or is it for any purpose?
Yes, this is for the purpose of observability. We need to monitor the Kubernetes cluster, right?
Kubernetes,
Cluster,
what
Kubernetes.
cluster? Okay, okay.
So There are so many tools are there to monitoring our cluster. For example, this cluster is in a production environment. We need to monitor, right? Monitor in the sense of like this. There are so many components in the Kubernetes cluster, right? Like node, pod, container, applications, then network, memory, CPU, all things we need to monitor. So we need to mostly we are using some open source applications. So common open source application is Prometheus Grafana, the integration of Prometheus and Grafana. So Prometheus will send the
Grafana has a UI also, right?
Grafana have UI, and that UI needs some logs and metrics to showcasing the details, right, of our targeted resources. In our case, our target resources is Kubernetes. So some application needs to send these things like logs, metrics, and so many things. So the Prometheus will do the
Prometheus will do that.
yes.
Okay,
So
okay.
the Prometheus will sending logs, metrics, all the things to Grafana. So the Grafana we can see like the graphical representation of our clusters, health, status, all the things we can see in Grafana dashboard.
Okay, so Grafana installation, we are doing it on our system.
Yes.
Okay.
Both are installed right now. See,
Yeah,
table
installed.
Grafana is here.
So, but in a real-time environment, all these, do we need to do it, or normally the systems that are being provided to us has all this stuff?
That depends actually. For example, if there is some, I mean, in coming to production, there is a observability tools there. So we just manage sometimes. Otherwise, we need to, if there is no requirement, then we need to commission all the things. Like coming to observability.
So for installing Grafana, we have specific commands. So for example, for if there is any other tool, so how do we get the commands for that particular application or tool?
You mean open source tool, right?
Yeah, any open source tools.
Alternative for Grafana Prometheus, right? You mean alternative?
Yeah, alternative.
For alternative, there are some tools are there. Like you can see the official documentation from the website. Actually, for example, there is a Loki there. Okay, so just you go to the Loki, there is a documentation for installing Prometheus. I mean, in Kubernetes, we can go with the there mentioned official commands. That's where we are performing these types of tasks. If the new applications, or in that case. Clear?
Yeah, got it.
For example, Jenkins, we don't know how to install Jenkins, right? So going to the official documentation of Jenkins, we can simply install Jenkins, right? We can just choose the machine type, I mean, Amazon Linux or Ubuntu. Then all the steps are listed in the official documentation. Just follow the command and we will get the Jenkins. Similar way, we install all the things like SonarQube. There is a documentation page for the, I mean, all application official page.
Sorry, guys. I'm new to this all these installation types. So
It's okay. No, don't be embarrassed. You're all learning.
yeah.
It's actually a lot of little details that you just have to patiently pay attention to, right? Nothing is hard in one step. It's all the little steps are basically how it works.
So now I
And
go.
mostly these are configuration related things. So every documentations are there. We just need to follow the steps one by one. All are like that. Maximum. Most of the things are like that. Lot of steps.
Yeah.
You need to follow those.
Okay, then I am going to edit the service table queue Prometheus is still Prometheus. Okay. So This is the service I'm going to edit. Okay. Here there are a lot of services there, right? 1, 2, 3, 4, 5, 6, 7 services are there. So I'm going to edit these services, the fourth one. Q Prometheus, STA Prometheus. See, this is the service configuration file for the application. Previously, we created service configuration file, right? So that's a small configuration file. Coming to this is a full-fledged configuration file. So the APIs version is V1, the kind is service. Then see, they are mentioned the version, instance table, managed by Helm, parts of Kubernetes stack. They included, I think they included the full version, full details for the application. If it is custom based application, then we only include the minimal details. So coming to spec, you can see the specification, the cluster IP there. Then coming to port, HTTP 9090, TCP 9090, and the port 8080 for the reloader web. These are some application integrated with each other. Okay, so mention all the ports are there. Both they mentioned all the ports. And see the type, that is cluster IP, right? There are 3 types of service are there. One is cluster IP, node port, and load balancer, right? So here we are going to change the cluster IP to node load balancer for accessing this application. By default, it's pointing to cluster IP. That's why. Now I am in which editor is this? Vim editor. Okay, this is a Vim editor. There are 2 types of editor in Linux. One is Nano and one is Vim. So coming to Vim editor, how we edit? Like first we need to type the I. Okay, in keyboard type I. That is for insert mode. Now, so you can see the insert is visible. That means we can add something in this existing command. Add or remove. So I am removing the cluster IP. Then I am adding load balancer. Keep in mind load balancer, how we type, like first letter of load is L is capital and B should be capital. Okay. Similar way, cluster IP, C is capital, then IP is I is capital, I think. Yeah. For node port, N capital, P capital.
So is it by default we have to change it to load balancer?
Yes. Now we are changing to load balancer.
Okay.
For
So
Kubernetes, we need to means consider type as load balancer, right?
for what? Kubernetes.
For Kubernetes services. Yes.
Kubernetes service in the sense of
Means for Kubernetes clustered, the type are free, right? We need to take load balancer as a type always.
no.
No?
No. Inside Kubernetes, we deploy application and we expose the application only.
Mm-hmm.
For Kubernetes, for I didn't get you the question actually.
Okay. Uh, you have covered that part. I think I was missing something. I will check the note.
Kubernetes, for example, consider this is the worker part. Okay, there are 2 nodes. In our case, there are 2 nodes. So we didn't expose the Kubernetes because we installed kubectl. So we can access this Kubernetes cluster, right? So using kubectl, we deploy application. So the application will create a pod and application container there. So we need to create a service connection for this. Otherwise, these applications only accessible inside the cluster, okay, not outside the cluster. Outside the cluster means internet. For accessing outside cluster, we need to create load balancer or node port. That is service, okay. Service is the service inside the pod actually. So that will expose this application to outer world.
Yes, yes. This was only I was talking. Like for three types are there. No, one was cluster IP. So for inside, we choose cluster IP the type.
Inside cluster
For
IP, yes.
outside, either node or load balancing.
Yes, outside means we need to access our application, right? That's why I'm going to change that to load balancer.
Right, right. Got it.
So inside mode, currently it's inside mode. So my editing is done. I changed to load balancer. So how to exit? Type X. So escape. Okay, escape key. Then double colon. Sorry, double dot. Then read and write. Okay, write and exit. So W for write and Q for quit. Hit enter. Fine. So this way we editing in Nano editor. Okay. So see service table, Kubernetes table, Prometheus edited. So similar way, now I edited the Prometheus cube stack stable cube. So I'm going to edit Grafana. So this is the service for the Grafana. Similar way, I'm going down. See the type is cluster IP. So I'm going to edit, insert, type I, then delete, type load balancer.
This looks like YAML file.
This is YAML. This YAML provides
YAML.
by the Helm, right?
Okay.
That's why we go with the Helm. Otherwise, we need to create the YAML for all the services, all the pods that we created. Okay.
So both Helm and Grafana provides YAML.
Yes. Helm provides
Okay.
YAML. Helm package manager just have the YAML file of applications.
And what about Grafana? It also provide Helm
Yes. Yes.
YAML file.
Yes. You see.
We are doing for both.
Yes. These are the applications we deployed. So each one
Mhm.
have Helm YAML file. Okay. So that applications have similar service connections. These are the services. So each service have each different YAML files. So all the things provided by Helm.
So which
Otherwise,
application we are going to access outside of from internet to Kubernetes? Is it Helm and Grafana to access those application? We are doing this?
sorry, once again.
No, no. We are editing the YAML file inside the package manager, Helm and Grafana. For what purpose? For accessing which applications?
Okay, first of all, I will
So this
briefly explain. Okay, consider this. Here we have 1, 2, 3, 4, 5, 6, 7 applications, sub application. Some applications have made the main application, and some others are the dependent applications. Okay, these applications are interrelated. Okay, so
These are inside the package manager, Prometheus.
yeah, I will explain. So
Okay.
7 applications are there. Coming to services, we have around 7, I think. 1, 2, 3, 4, 5, 6, 7. 7 services. Okay. 7 services are there. By manual way, we need to create 7 plus 7, 14 YAML files. Right?
Right.
14 YAML files. For
each service?
yes. Not for each, for all the service. Because there are seven deployment in our case, and 7 services are there. Remember previously we deployed a simple application. We need to create a service for for deployment, and to expose that application, we create another YAML file. So there is 2 YAML file. Similar way, in this case, we need to keep 14 YAML file. So we have one option. We use Helm. So using Helm, first we install the Helm, and we search for this requirement like Prometheus Grafana. And Helm say yes, the package is in with the Helm. You can use the package. Package manager. So it will have all the YAML file, all the details. Okay. So we use Helm and download the stable URL, all the things. Then search for the Prometheus Grafana. Then we install this Prometheus Grafana stack in Kubernetes. That part's done. Yeah, Helm part is done.
Does Helm generate a lot of YAMLs files for us based on some rules or some it understands?
No, not the rules our search. Used by our search actually. What are things we search? The Helm will provide the things. If you are okay with the Helm listed application, then we can easily install we can easily deploy the application instead of bothering about the YAML file.
But Helm generates the YAML files, right? Or no?
Yes.
Oh.
Not it's kind of a generation. It's actually there is a community base. When we installing this, you can see like this. See, first we using Helm repo add. Okay, this is Helm repo add command for the Helm. Then we provide the Prometheus community, and we provide the HTTP Prometheus GitHub Helm chart. See, this is a URL. Okay, so the Helm will download all the things from the URL. You can check out the things. Okay, like see, from here we download the things, right? Charts, go to charts. See, I think we can install the Chrome Prometheus stack. From here, it will download actually. Here the charts are listed in the GitHub. Using Helm, we install the chart actually. Then we install the Prometheus community from this existing URL. Then we install the same thing like Prometheus community, Prometheus stack. Got it?
Yeah.
See, after editing, we will get 2 URL that is pointing to load balancer. One is Prometheus Alert Manager and one is Prometheus Stable Cube STA Prometheus. Oh, one is for the Grafana and one is for the Prometheus. So coming to the logs and metrics, we need 2 things. Like one is Prometheus UI we need for configuring. Otherwise, it will sending the default logs and metrics. Then for Grafana, surely we need the URL because we mostly work in Grafana UI. So monitoring, configuring all the things. So using the URL, we can access, okay, checking the accessibility. See, Grafana. This is the Grafana UI. Admins, I think. Admin. From operator. That's the password. Yeah, it's logged. So this is our dashboard, Grafana dashboard. Okay. So this Grafana application running in our EKS cluster. So here we configuring, I mean, same, we can onboard the Kubernetes cluster in here. So here we can monitor the Kubernetes cluster. We can set the alerts, or you can set, for example, we have two node, okay, for each node, or in case if the node CPU utilization is high or the memory utilization is high, we can set the alerts based on the requirement. So here we will get the alert or mail notification like that. So we can check the cluster health accordingly. So go to dashboard. Now it's empty. We need to onboard our application or Kubernetes cluster or anything. See here, there is a no dashboard, import dashboard option there. So import dashboard, then need to load. There are some numerical numbers are there, okay? So like this 611712. These each ID for Grafana dashboard, okay? For each ID. So for example, if I choose 6417, okay, then load. It's I think expired to load. See, that 12324, I think that's the ID number. That is for Kubernetes monitoring dashboard. Okay, for each ID is pointing to different services.
Is
This
that
service,
IDs fixed?
sorry,
Fixed? Is the IDs are fixed for
yes,
that?
yes. It's visible in the document, official documentation. We can see that IDs for each requirement. We can provide the URL or ID. Then next thing is we need to choose the source code. Okay, as of now, Grafana didn't know the logs and metrics where I mean from where the logs and metrics. So we need to choose the corresponding source data source. Okay, so here drop down. By default is Prometheus, but in our case it's Prometheus. So we can choose Prometheus is our source data source. Then import. So it will fetching the detail from Prometheus because the Prometheus is running in our Kubernetes cluster. See, some data are here. These data are from our Kubernetes cluster actually. So this will take some time, like our cluster memory usage, CPU usage, all things. We have a total 4 GB memory RAM, right? We have two node are in our Kubernetes cluster. That's this. Then port CPU, node data, going to container CPU. So these are the containers we install. See, container memory usage, container network, system CPU, So this way we created dashboard. This is a Kubernetes monitoring dashboard. So here we need to monitor, create alert based on the requirement. For example, these are the requirements like container memory usage or container network IO. If we set our limits actually. So if exceed our limit, then it will. So I am going to import some other like 1868 is. Yeah, this is for not exporter full. I will check that thing too. Cancel. Prometheus. We need to choose the data source, okay? Because the Prometheus running in our human cluster. So this is for not exporter full detail we will get. So these are the details. See, our CPU busy in total 3.6. System load is 7%. RAM used 39%. Swap used not applicable. Root FS used 5.7. See, this way we monitoring the CPU memory stack. These details from the node exporter, okay? Memory info. Yes, this is just started. That's why it's from here. Okay. Then I will go to add one more dashboard. Kubernetes cluster. Yes, this is a Kubernetes cluster dashboard. Okay, not Kubernetes cluster monitoring dashboard. So here we can see how many deployments are there. There are 5 deployment. Number of pod 2. Here we can see the deployment. Okay, DNS, Grafana. Then container running. 19 containers are running in our Kubernetes cluster. Some data are not fetched actually. Container terminated 0. Container waiting 0. Port succeeded 0. Port unknown 0. Port failed 0. Running port 13. So these are our deployment, 5 deployments. So we can go with one more deployment like simple deployment. We can sometimes we can just deploy some small application and we can see that application is fetched automatically in our Kubernetes. Okay. So before we deployed the Angular application, right? All of you.
Did something in the
Yes.
way your mic changed, the position of where you're holding it, or some?
Now it's clear, right?
You sound very different. Yeah, now you sound better again. Yeah.
Yeah. I mean, I asked that before we deployed Angular application, right? All of you. That is
Yes.
like which way I mean that used by the YAML, right? We can deploy application without YAML. We can directly pull the image like kubectl run command. I think we done in the minikube lab, right? Like for example, if we are going to install Nginx observer, okay, like kubectl, then run command using kubectl run, then we need to mention the deployment name, okay, like run. We can directly downloading some images from internet. Nginx deployment, then we can the image, we need to mention the image, right? Image is equal to official image name is Nginx, okay? It will downloading from Docker Hub, Nginx. Then the last thing is what? All of you forget all the things, right?
Do you need to put the Nginx colon latest?
No. This will download the Nginx, but the next thing is the main thing.
Application name.
Application name already mentioned. The kubectl run Nginx deploy. That's the name. This is a name.
So where we should deploy that location path?
Not path, because this I'm talking with the kubectl, so it will deploy in Kubernetes.
You want Nginx to run Grafana or Prometheus?
No. This
No.
will run separately, no problem. But the Prometheus and Grafana will take the details of the new deployment, the name, all the things. We didn't bother about that thing.
Are you installing Helm then? Like
Helm?
they need Helm in the command? Yeah.
No. I
No?
told you, Helm is only for that package manager, for the Prometheus
Oh, okay.
Grafana. That's, you can leave that thing. For this replicas, here all of forgot, right? Replica means first we are talking with the Kubernetes. Kubernetes, please run this deployment. The deployment name is Nginx deployment, and this is my image. So I mentioned the image is equal to Nginx, and we need to ask to Kubernetes, like I need to create 2 pod or 3 pod or 5 pod to deploy the following application, right? So we need to mention that thing, and replicas like 5. Then hit enter. Replicas. Replica.
Maybe it's -R 5.
Lab replicas is equal to 5, I think 2. Which are Amol?
Yes. What are you saying?
You mentioned some R.
Yeah. Instead of the -- replicas, maybe -R and then space 2.
No. This is fine actually.
This will work.
This won't work actually.
I was just Googling the command. Well, maybe try replicator, -- replicator, or replicate. Try replicate.
I will mention the deployment to deploy.
You want to replicate the pods in Kubernetes, right? So
No, this will create two replicas or two instances of our application.
but they two instances they will be running in their own, each will run in their own pod, right?
Create two pod with the two container.
Yeah. Or one pod with two containers.
No,
Does it matter?
No.
Two pods with one container each.
Yes.
Okay. Try replicate equal to 2. -- replicate equal to 2.
Replicate, CAT.
Yeah. Yes.
Not flag. No, we used a replica actually. Replicas. But not flag.
You have to add replicas from Kubernetes dashboard. Right. I think you have to put scale, keyword scale before -- replicas.
No.
No?
This is actually we can directly install using the kubectl run command for the deployment.
Some of the commands I'm Googling, it says scale. The word scale is before the word replicas. kubectl scale.
A second, I will see this one. I'm going to top here. Okay, that will create it like kubectl run to-do list app, the application name, image is equal to react that kubectl get pod. So the to-do list application deployed. Okay, so we can just search kubescale replica. Okay, I will check that thing too.
Just add the word scale in front of the in your command. I think you have two kubectls in the command now. Just take out the second kubectl.
No.
Maybe you break it into two commands like kubectl scale replicas equal to 2 run nginx.
Which one?
So sudo kubectl scale -- replicas equal to 2 run nginx -- deployment -- image equal to nginx. So just put the scale replicas equal in the earlier after kubectl.
Yeah, I will try. Okay, before that,
Okay.
I just in this case we already deployed a application deployment, so it will see here. As of now, it's 5. Just reload. To-do list is not listed here. Okay, but our latest deployment is not fetched here, that to-do list tab. Actually, it will be here, I think, some configuration issue or anything like that. The configuration issue is based on the Prometheus actually. So Prometheus and Nodeport. So that services will getting the details of the new deployments and sending to the Grafana. Yes, I think for the default, when we're choosing the namespace to default, it will show there are one pod is running and one container is running. Now it's listed. See, this is actually to-do list, the latest application that we deployed. But we didn't get the full details. It will take some time, I think. So anyone have any doubt?
Our replicas keyword didn't work yet, right? So, or did it work?
Replicas not work.
Okay.
That's the command. I think this is some permission issue or anything. Instead of, for example, instead of Nginx, you can try with Apache, okay? Like kubectl run Apache deployment. A module, right?
Yes,
Yes.
we can hear you.
I will add the latest to two, so we can check like. Again, it's showing like this.
It's parsing it like replicas is part of the run command, right? So that's why it's not working.
Yes.
Maybe break the command into two pieces, like where you start the server and then you scale it.
Sorry. The mission is hanging actually. Yes. I think. Okay, I think some related to the replicas. Okay, before we wait. Yes, replicas. Made in Nginx. Okay, now we deployed Apache and Nginx with the default port. Okay, we'll check that. kubectl get. If we get all the ports, then port -a. Sorry. See, it will list all the boards. See, some application is pointing to default because we didn't mention any like namespace. So that application will under the default namespace. Nginx deployment there, to-do list there, and my Apache there. There are 3 applications we deployed. These 2 are web servers and one is to-do list application. Then it will be listed here. I will add more time. Note. All right.
So, Tawfiq,
Yes.
one quick question. So normally do we create the image like, I mean, like in the container, using the container with all these things and then deploy it, or in the real time, or because it's not one server, right? It would be multiple servers.
Yes.
So
Yes.
the image will always can be used, right?
Sorry. Image.
The image will be deployed, right?
Yes.
Not individually deploying all this stuff.
Yeah.
Okay.
There are different IDs are there for the Kubernetes, but common service, so common IDs are, we use some common IDs actually. So anyone have any doubt as of now? All of you?
Perfect. I mean, like, as I said, like we normally, I mean, like in the real time, we have to do it on creating an image and then deploying it, right? But why are we doing it not doing it in container and doing it individually on different machines like that?
Different machines in Kubernetes, right?
Yeah, I mean, like, why are we not using an image here?
Your question, why are we not using image, right?
Yeah,
In which image you mean?
because
Application?
because yeah, because in the real time, we normally have to do it or deploy the image, and because it has to be in multiple servers, right? So
Yes, there are two scenarios, Krishna. One is custom, then the next one is open source. For example, we need to deploy application, right? So we need to create a image, create a YAML file for our custom deployment of application. Okay. So this is one way. The second way is we can directly download the image from from the corresponding, like for example, Docker Hub. Okay. So these are the two way. So the first way, custom made, in customer case, we have one image in Docker Hub. Okay, consider before we create a Docker file and we push the Docker image, create Docker file, then build the image. Then build image is in our Docker Hub or any repository. Consider it's a Docker Hub. So we have the application ID. So when creating the YAML, we need to mention the image name is equal to this image name we need to mention here. Then we will apply this to Kubernetes. In this case, we can directly taking the image from using a simple command. This is declarative mode. Okay. Creating the YAML and I mean, customize the details, all the things, and applying this to the Kubernetes cluster. This is imperative mode. We can directly using kubectl run command. We can directly pull the image from Docker Hub. So we just mention the image and the image name. The image name and image the image name is unique. Okay, unique in Docker Hub. So it will go to the Docker Hub and pull the image and deploy it in Kubernetes. Two-way we can deploy application.
Okay.
Hope you got the point, right? Or
Got the
confused?
point. No. I got the point. But in I mean, when you're working with any of the systems, so how
Hmm.
many times do we end up doing it individually rather than using an image? So it's mostly the image that we in the real time we'll be using the images only, right? I mean, like
Hmm.
in very rare scenarios, you do it individually. That's what I think. But let me know if I'm wrong.
In
Correct me if
coming
I'm
to
wrong.
organization, okay, then we need to create the YAML file, right? I mean, as per the client requirement. For example, some application we need to deploy. So we need to protocol the YAML file. I mean, sometimes developers will provide the YAML file. Otherwise, we need to create the YAML file. We will get the templates actually. So we just customize the requirements in that YAML. That's where we are going. We have some templates, right? So for example, simple application template. So we just change the requirement, like replicas we need to change, application version change, name change, metadata change, image change. These are the common scenarios we are following. Got it?
Okay.
So anyone have any doubt? So our lab is to deploying Kubernetes, I mean Prometheus and Grafana for observability purpose. So we deployed that thing in Kubernetes.
I'm not able to connect my local system via SSH
You
to instances in AWS. Once
are you
again,
facing the error, right? Could you share the screen?
every time it is throwing the same. I was facing the error. I did nothing, but it worked as it is, and
Could you
then
share the
again
screen
started.
to have a look?
Yes, yeah. Because same error I was facing when I am trying to connect Jenkins server to access Jenkins server to the prod server. It is showing the same error, like because the permission denied. I think it because of the same reason. Let me share my screen. Is it visible?
Yes, it's visible.
I've deleted the instance